Yeah, what's up, guys? This is the Philosophical Doomer, aka Luplinia. And what I wanted to talk about today is uh, you gotta take the crookeds with the straights, or uh, the the pros with the cons. And I'm starting to realize that as I get older. Um, like when I'm in school or whatever like that, like on some labs I do good, and I get most of it, and then on other labs I get like I'm just I don't exactly get it the first time or the first couple times um, when I do it. Um, like for example, so basically, just to give you an overview, the uh, the engine in the car is pretty much like an air compressor. So the only thing we're doing is the only difference is you're adding fuel and spark to it to so you can get a nice evenly spread fire across the top or combustion. Um, so in order to test the health um, of an engine or the health of an engine cylinder, you have to do a compression test. You have to compress air uh, inside of it, and there's a tool to do it. I forgot the name of the specific tool or whatever like that, but there's a tool to compress air in the cylinder. So pretty much what you have to, I'm not going to go through the whole entire process of what you have to do. You have to do like a whole bunch of stuff. You have to like put the cylinder at top. You have to put the piston at top dead center, and all this other stuff. But it's basically when a cylinder compresses air, it's only like about like 20% of the air is escaping. So that engine is only compressing about like 80% of the air. Is only compressing about like 80% of the air. So you know what I'm saying? You kind of want, if you want, so if the engine's only compressing about like 80% of the air and is losing 20%, you kind of don't want that engine to lose any more air, because the less air is compressing, the less power it'll have, or whatever like that. And um, the compression, when you compress air, it can't be each and every different manufacturer for a car got their own specifications or whatever like that, or how much it should how much air you should be losing when you do a compression test. But it shouldn't be any more than like it shouldn't be any more than like 10%. And then when I was doing the compression test, I was pretty much like my numbers were pretty much like every fucking where. And some people said it was the car, like because like the cars that we use in my school, like a lot of those cars are like damaged or like flooded, and they're really like we got many different like bunch of cars in my school. We got like Nissan, Subaru, Toyota cars, and the teachers say they're a donation from those companies. They're donations. Um, so pretty much, uh, I don't think it was the car though. I mean, I think that's just like for me to say that uh, it was the car and I had nothing to do with it is an excuse, because other people's results were looking pretty good. When I was comparing my results to other people's results, because I tend to do that. I compare my results to other people's results to make sure I'm on the like the right track or whatever like that. And my results were like terrible. I was losing like 50%, 60% of the air or whatever like that. And I did bad on that lab. I did bad on that lab, and I felt down on myself or whatever like that. But like yesterday, um, and even today was my last day. My last day for that class. Um, so like yesterday and today, it was kind of, at first it was annoying, but then it became kind of fun. So like he was the teacher. He pretty much already had like the cars bugged. So we had to figure out the bug. We had to figure out what was wrong with the car in order for the reason why it wasn't working properly or whatever like that. We had to figure out how he bugged it, and he put me on the car, and I pretty much like I was more I was more confident. Like I knew what tool to use. Like I knew what tool to use. I knew how to hook it up. You know what I'm saying? I pretty much knew what I was doing. You know what I'm saying? But The only reason why I did that is like the only reason like how I knew what I was doing. Like I started from a point where like I had no fucking idea what I was doing, but um you keep doing it over and over again, you get a good sense of like, okay, this is what I need to do, or whatever like that. And first thing I need to do was like grab the scan tool, or whatever like that. So I grabbed the scan tool, and an ignition code pops up, and the ignition code was like ignition coil primary B, and that pretty much really doesn't tell you anything. The only thing it tells you is that there's an ignition coil problem, and a lot of people think that a lot of people, like, you have a lot of people, like, I listen to like some videos online, and you have a lot of people think that like you can just hook up a scan tool to like a car and it just tells you the problems, when right, when in actuality that's not true. The scan tool is like it's a tool. It narrows down the problem. That scan tool might give you a symptom of the problem, or it might hint at the real problem, but it doesn't necessarily tell you most of the time the actual problem. You have to use your expertise and your knowledge on how cars work in order to figure that out as a tech. Um, but it was like an ignition coil problem, and we knew when we cut the car on, we knew it was misfire. And the way that you get a misfire is I don't mean to use too much automotive terminology, but when you have improper combustion. So like um, there's something wrong with there's something wrong with the spark plug, maybe, or something like that. And or the, like, in order for you to get in order for you to get combustion in an engine, right, you need spark, you need fuel, and you need air, right? So if that cylinder is misfiring, or your engine is misfiring, or whatever like that, it's improper combustion. It has to be one of those three things. And from the scan tool, like I just said, from the scan tool, I knew that it was an ignition problem. So I knew the reason why it was misfiring. It was on the ignition side. It was on the spark side. The spark plug goes right on. Well, you have two different systems uh, of the spark plug. So you have like ignition on coil, where the ignition coil goes on top of the spark plug, and then you have another system. I think it's called like DIS, where you might have one um, ignition coil for two spark plugs. Anyway, I'm getting into too much terminology, but pretty much this was a coil on plug. So each and every spark plug had their own ignition coil. Um, so pretty much we knew that it was an ignition problem. So now we had to like isolate the problem. Where, okay, we know it's misfiring, but we don't know what cylinder is misfiring, and and I didn't I forgot about the techniques that like he taught us. And he came over here, and I'm like, okay, wait a minute, like, what do we do, or whatever like that. He was like, last week I taught y'all two techniques how to figure this out. And once he said that, it came right to me. And what you have to do is each ignition coil, they have a connector. So what you do is you pull each and every ignition coil connector one at a time, and you see if there's a drop in RPM. RPM is how fast the engine is turning, right? You see if there's a drop in RPM, and if there's a drop in RPM, you know that's not the cylinder. You know that cylinder is fine. But if you pull the connector to the ignition coil, and there's no drop in RPM, you know that's the cylinder that's misfiring, because it's not doing anything. All right, so we pretty much isolated the problem. Well, I did, because I'm pretty much in a group where, um, let's just say I'm in a group where I'm forced to pretty much take the lead and take control and pretty much direct the group. I'm pretty much the leader of the group. Um, I'm pretty much the leader of the group, so I have no choice. I'm in a position where I'm the only one that can really do the work. You know what I'm saying? So I pretty much do everything. Um, and we pretty much isolated the problem. It was cylinder two, and now it's like, okay, we know the problem is in cylinder two, but we have to make sure that the problem is in cylinder two, because it might not necessarily be cylinder two. It might be the ignition coil in cylinder two. So the next technique is to switch the ignition coils, right? And if it jumps, if the misfire would jump or whatever like that, we would know that it's the ignition coil. The ignition coil is defective. All right, something's wrong with the ignition coil. But we switched the ignition coils. We switched them, and then we switched them back. We switched them, and like it was the problem was still in cylinder two. Um, so it wasn't the ignition coil itself. It wasn't the initial coil itself. So I'm like, okay, well, shit, what can it be? And he pretty much gives us like hints and stuff like that. Like, okay, well, what do you need in order for this initial coil to work? Well, you need three things. You need power, you need ground, and you need signal, right? The ECM, pretty much gives it the signal, gives the ignition coil the signal to work or whatever like that, and it needs that ignition coil needs power and ground in order to actually work. The ECM just sends the signal or whatever like that, but it needs power, and the ECM also sends kind of like the power to also make it work. But like those are two different wires though. The power wire is its own wire, and the signal wire is its own wire. Um, you know what I'm saying? So pretty much after that, we pretty much, long story short, um, we pretty much found out that, so basically, in order for electricity to work, or um, in order for something to, like a light bulb to cut on or something like that, you need two main things. You need power and you need ground, right? And you need three main things. And if one of those things are not working properly or whatever like that light bulb or whatever you're trying to power is not going to cut on. Um, you know what I'm saying? So pretty much, long story short, we, you know what I'm saying? It's this meter we have at school. So basically, with the scan tool has like a scope on there where, so you can pretty much, we call it front door information, where you can pretty much see what's going on at the sensor in terms of like waveforms and stuff like that. So the ECM sends like a 5 volt reference or whatever like that, a 5 volt reference to the sensor, and the sensor has like resistors in it that cuts, what I'm saying, that voltage into like 1 volt or like 2 volts. It cuts it down or whatever like that. That's how it works. And basically, um, we're supposed to be seeing, he pretty much gave us that hint, and he went from the negative terminal of the battery, which is ground, right? And he was like, my ground. He's like no, first he did power. You know what I'm saying? He was like, okay, right? He did the power one. He was like, okay, I'm getting 14 volts. That's correct, right? And then, matter of fact, that he didn't even do it, right? No. So what he did was, yeah, he showed us. He was like, okay, well, listen, it's not, what I'm saying, it's not the ignition coil itself. So, it has to be, what do you need in order for that ignition coil to work? And then, power, ground, signal, whatever like that. And we pretty much had to check those. And I checked those or whatever like that. I checked ground. I had 14 volts, which is good. And then I checked the signal wire, and I had voltage, right, which is also good. And I checked the ground or whatever like that. The I went from the ground terminal of the sensor to the negative terminal of the battery, and the ground is supposed to be zero, right? Because all that voltage is supposed to be used, but the ground was 14 volts. You know what I'm saying? Which pretty much says that the ground was open. You know what I'm saying? And that's why the ignition coil wasn't working, because the ground wasn't open. And pretty much, I say all this to say was that, I was kind of proud of myself that I was able, even though he was like giving us hints and stuff like that. I'm proud of myself that I actually, kind of like I was able to like figure that out. You know what I'm saying? And he puts us on another car, and same thing. I was close to same thing. But the only difference is, he was like, so like, what is the first thing you're gonna do? And I was like, okay, we're gonna back probe. Back probe is like when you hook it up to like the scan tool, and you're looking at the voltage signals of that sensor. So like the voltage signal that sensor is producing, you're looking at the waveforms on the scanner or whatever like that. And long story short, I found out that I actually was doing it backwards. The first thing I was supposed to do was what I did on the first car, was like connect it to the scan tool and then look at the live data stream of what was going on at the sensor. Because long story short, he pretty much the ECM, or what the ECM is, the computer in the car. I know I'm using too much automotive terminology. The ECM is the computer in the car, and the computer has multiple ECMs. You know what I'm saying? It has multiple ECMs or whatever like that. But this is the ECU or the ECM to the engine specifically, right? Specifically the power control module. Um, yeah, specifically um, the power control module. Um, and pretty much long story. I know I keep saying like long story short. Pretty much it. Long story short. I was doing the whole goddamn thing backwards. I should have did what I did on the first car, connect the scan tool, and I would have seen that the ECM was not communicating with the sensor, right? Because when we were when I like when I was doing stuff at the sensor, we got a signal, like the ground was good, all right, the signal was good and the power was good, but the yeah, the power was good. Yeah, the power was good and the ground was good, but the the sensor was saying that it was getting the signal, but it was kind of like it was false information. Because when you hooked it up to the scan tool and you looked at the data from the ECM or whatever like that, using the scan tool, like you would see that, right? The like you weren't getting anything. It was zero. The amount of volts or whatever like that, it was zero. You know what I'm saying? You weren't getting anything. You know what I'm saying? So pretty much I found out that I was pretty much doing the whole goddamn thing backwards. And I'm like, I kind of like threw up my hands like, oh damn, like you may be going the wrong direction on purpose. And my teacher pretty much was like, like you're learning. You know what I'm saying? That's how you learn. He was like, if you get everything right the first time, you're not going to learn anything. You learn by failing. By failing over and over and over and over and over again. You know what I'm saying? That's how you learn. Um, and I can see myself now, like even today, like, we were pretty much doing the same thing as like something similar to what we were doing yesterday, and I was more confident. I knew exactly. I knew. I'm not gonna say I knew everything of what to do. I made some mistakes along the way, but I had more of an idea of what I was doing than before. You know what I'm saying? So it's just taking your time, going at your own pace, and taking the crookeds with the straights. You know what I'm saying? Um, some days, some days you're not going to do well. Some days you're going to do better than others. But yeah, um, I think I'm just going to keep moving forward and then see where it takes me. And that's that's pretty much it. Move at your own pace because you have to take the crookeds with the straights.